Hello everyone, this is Junyi Huang from Tencent with my colleague Pan Liu. Today we will talk about our practice of Presto in production at Tencent. Here is the agenda. We will share about the current status of Presto at Tencent and what we have done for Presto, such as usability extension, stability improvement, and performance optimization. Let me first introduce our team. We are a big data team from Tencent, including SuperSQL, Presto team, CornerGDK, and Kubernetes team. We focus on developing and building a big data platform for Tencent to provide users with the ultimate performance experience. Our scenarios include ad-hoc queries, interactive queries, and others. At present, Presto has been deployed more than 500 workers in Tencent, with 100,000 queries per day, a data volume of more than 2 PB and 90% of the query time in 50 seconds. Our Presto business is still growing rapidly. Volume may be double in the coming month. This is the architecture of how we use Presto. The top layer is SuperSQL. SuperSQL is a unified, intelligent, and cross-engine SQL layer. It can provide authentication, SQL parsing, SQL optimization like IBO, CBO, and HBO, and other capabilities. After the user executes the query, SuperSQL can automatically identify whether the query is a large query or a small query. Complicated and batch queries will be dispatched to Hive or Spark, while small medium queries will be routed to Presto. This process is transparent to the user. For Presto, we deploy it on Kubernetes in a multi-cluster manner. Different user groups will have their own Presto cluster. The advantage of this is that clusters can be isolated to avoid a mature inference. At present, we mainly access the following data sources through Presto: HDFS, Iceberg table, and MySQL. In addition, we also use Elastic Cache to improve the query performance of Presto to access HDFS and Iceberg table. In the second part, we will introduce some of the functionality and easy of use work we have done on Presto. The first introduction is the features of compatibility with Hive. We have done some Hive syntax compatibility related work, such as Hive UDF support, region hint, and implicit type conversion, and so on. Region hint actually correspond to the broadcast join of Presto. The user can specify the table to be broadcasted through the hint, and the major hint table will be broadcasted as a build table to each worker node to participate in the join process. Currently, the major hint supports inner join and left join. For implicit type conversion, it is mainly the implicit conversion between numeric types and virtual type, which we also try to be compatible with Hive. We also implemented EvenListener plugin to write query matrix information to the local disk and also store it to the message queue, including query basic info, query time info, stage statistics, and task statistics. Those information can be used for SuperSQL HBO, performance analysis, audit logs, history server, and other purposes. Here are some scenarios in our company that need to be able to dynamically add catalog without restarting Presto server. So we have also implemented the feature of dynamic catalog through the DEL statements such as create catalog. You can see when the coordinator receives a create catalog request, it will store the catalog information to the catalog store, which can be a relational database or others. Then the coordinator will communicate with the worker and send a request to create a catalog. The coordinator and the worker will also verify that the created catalog is the same to ensure consistency. It also supports job catalog and show create catalog statements. Currently, it only supports dynamic creation of MySQL catalog, and this is an example of this. About Iceberg Connector, we use Presto Iceberg Connector to query Iceberg tables in data lake. Here is the typical scenario. Data from log or message queue or RDBMS is added to data lake store as a Iceberg table by Flink. Then we use Presto to do some near real-time analysis for cross-data source data. For example, we may join an Iceberg table with the Hive tables and then may rewrite the result into another Iceberg table. Such actions need to be finished in seconds or minutes, so it is quite suitable for Presto. So as the list shows, we did some improvements and buffets to Iceberg Connector to make it stable enough for our product environment. For example, we add the support for ORC format and add a large local cache for Iceberg Connector and fix some bugs as well. Those features and bug fixes can be found by the links on the slide if you are interested. In the third part, we will share our work related to stability improvement of Presto. We have done a lot of work on JVM Tuning. We first used the JDK8 version, the Presto product environment, but when the memory is large, such as 180 GB, the FreeGC post time is very long, reaching tens of seconds. Later, we upgrade to JDK11, and the overall FreeGC post time dropped to less than 10 seconds. In addition, in order to reduce the probability of out of memory, we also adjust the parameter GC local retry allocation count, increasing the value of this parameter, avoid giving up allocation too early and through out of memory error. We have encountered the following situations in the product environment. The heap utilization was almost 100%, but the general pool still had free space, and an out-of-memory error occurred later. So we add a new pricing, which can query when the workers are still out of memory even after full GC. This is how this policy works. When after full GC, if the use heap memory is still beyond the full GC query heap threshold, then the policy will choose the query using the most memory on the workers to queue. This can avoid out-of-memory error to a certain extent. And about reading ORC file, we may encounter worker out-of-memory situations from time to time because ORC stripe statistics occupies too much memory. This situation is generally caused by the ORC file being too large. This is a heat dump analysis report of an out-of-memory worker. As we can see, the retain size of Oasis Strap statistics is 140 GB, while the mass heap size is only 180. The Oasis Strap statistics object occupies the most heap memory. There may be two solutions to solve this issue. First is to split one big Oasis file to smaller files with a proper strap size, but it brings the risk of modifying users' data. And the second is to try to optimize Oasis Reader in Presto without reading duplicate strap statistics of the same Oasis file in different splits. Currently, we are working on the second solution. The picture on the left shows the current implementation of Oasis Reader. As you can see, each table scan split may reduplicate file metadata, the same Oasis file, if the file size is too big. So we are trying to optimize this behavior by only read file metadata once. The split filter will do this job, and the new table scan splits will no longer need to read file metadata again. Our initial test shows that solution 2 can significantly reduce the memory use of Oasis Strap statistics, which gave us confidence to continue our work on this feature. We also done some other jobs on stability improvement, like an independent cluster for important business units with different types of workload. We also limit the amount of query split, avoid big queries and other queries with too many small files, and a fallback mechanism, auto failover from Presto to Hive or Spark by SuperSQL, which is transparent to the user. And we also decrease the value of the HDFS client parameter, Hive HDFS timeout, to avoid waiting too long when reading data from HDFS data node. The next is the Elastic part. We use Elastic to optimize the query performance. Now my colleague Pan Liu will share his work about this part.
Okay, hello everyone. These are the two deployments of Presto on Elastic Tencent. Okay. The first is the most common way to deploy Elastic to a Presto cluster. The Presto workers and Elastic workers are placed on the same node to improve the date quality. The SSD or memory or HDD is used to use the Elastic storage according to our different requirements. But the problem of this way is that the Elastic worker will take up some resources from Presto, such as CPU or memory or something else. Also, it's much heavy to maintain Elastic cluster addition to Presto. So we are trying another way to use Elastic on Presto, the Elastic local cache. It's a much lighter way. We do not need the Elastic cluster, only the cluster Elastic lib is enough for the cache. However, this way may not work that well as the first way, since no Elastic master to coordinate the cache resources, and the Presto worker can only read from the cache on the same node. But it's more suitable for the cloud scenario because it's light enough. Still, we are using the first way mostly. As mentioned before, the Elastic cache is expensive and limited, so we need to control the date to be cached. We only want to load the hot date to Elastic, so we implement a Presto Elastic module to handle the issues related to Elastic. Here is how the module works. In brief, the Presto Elastic module works as a date router, which chooses the date to read from Elastic or HDFS. we can specify different policies to a different connector by configuration. For example, the Hive Metastore router uses the Hive Metastore service as the MIDI and is driven by an external preload tool to route the date. But in most cases, we use the whitelist policy. Firstly, the users can add database tables or partitions to the whitelist file, and it supports multiple Electro clusters. Then the whitelist router can match the locations of data to be read. Then the module will check whether Electro cluster is healthy before making decisions in the plain stage. Then after that, the splits are handling by the workers. There is a last check of Electro location to see if the Electro location is available. The worker will switch, if the location is not available, the worker will switch to HDFS automatically. But if the reading from Electro failed, the whole query will fail. We're still working on the fallback process to improve the Electro stability. Lastly, the date cached in Electro will not be preloaded to Electro before. Only reading the first time will invoke the Electro to load the data from HDFS. The data will expire or evict automatically. Okay, this is how we use Electro on Presto. Okay, this picture shows the improvements of our real user cases in our production environment. The Presto on Electro can give about 20% or to 30% improvement on some cases. Okay, that's the part of Electro.
Okay, thanks, Panel. And let's continue. As we mentioned before, our Presto clusters are deployed on Kubernetes, which can provide the ability of auto-scaling for Presto workers. We use Tencent CLB as a load balancer, so the discovery lookup will be like this from worker pods to CLB to coordinator pod. And the client also connects to coordinator pod through CLB. The worker's auto-scaling is based on the worker's CPU utilization and heap memory usage. Our goal is to maximize the utilization of the resource pool. So there will be a dedicated resource for Presto to ensure the minimal workers of the cluster. If the rest of the resource pool is free, the workers can auto-scaling to the maximum amount in theory. Okay, the next optimization is count distinct rewrite. In some cases, use smart distinct feature may cause data skew, which can have a significant impact on query performance. For example, count distinct over left join. If left join operator produces too many non-values, you can see from the left, data skew is slowed down the entire query. After we rewrite count distinct to grouping sets on the right, the data skew has been eliminated by partial aggregate, which gains 2 to 3 improvements on some user cases. The last is a user case of optimized reparation. In this case, there is a wide table with more than 800 in columns joined with a small table. You can see the exchange data size is 90 B. That's really huge. But thanks to this feature, the query elapsed time dropped from 11 minutes to 6 minutes. And the CPU authorization reduced to 50% on average, which is a really amazing improvement. There are some ones we plan to do in the future. First is to support temporary table and view. There are some issues about this feature, but not closed yet. So we plan to implement this feature, which is also useful in our scenario. Second, implement a history server for Presto. That is a very helpful feature for the developers and maintainers of Presto. The third, adaptive is the execution of the machines with different hardware resources, and so on. That's all. Thanks for your listening. If you have any questions, feel free to contact us through emails. Thank you, guys. Bye.